So students, let's discuss next model, that is finding square root or using the property of square root. So where this property of square root can be used. For example, this is one of the previous year questions that is asked in Rohtak. They asked what is the square root of 5 nines. Here in the given options also, I hope in the given options 316.226 is there, 316.224, 316.225, 316.223. So something like that, like this is there. So many students get confused when they ask you to find the square root of this, and they end up choosing a wrong option. Sorry, this is 316. Okay, and choosing a wrong option. Why? Because they will come to a conclusion that whenever there is an ending number, the number ending with 9, the square root will obviously end with either 7 or 3. So in the given options, which number do have an ending digit 7 or 3 will be taken as the answer. But unfortunately, that answer is wrong. Why? Because this is not a perfect square, right? So to find this perfect square, it's better you go for a long division method. How you will do that long division, I'll say in this, but don't go or don't use this shortcut. Okay, finding square root through this last digit. Yeah, sometimes if it is a perfect square, you can use that method. I can easily say 361. What is the square root of 361? If you know this, please comment in the comment section. 361 root is either that square root can end with 1 or 9. Okay, and next I have to cancel these two things, and I have to see to which square this 3 is very near, either 1 or 2. But I hope you know that this 3 is very near to 1. So either the options, the answer could be 11 or 19. But we already know 11 is 121. The square of 11 is 121. So obviously the option is, the right answer is 19. So this is one way generally students apply to find the square root of these numbers. But it's not actually valid or useful in this type of problems. So how to find this square root? So we follow the long division method. Okay, we take the numbers in groups of 2, but if it is an odd number of numbers, odd number of digits, then I take the first number as one group. Okay, first digit as the one group. Now this first digit is near to which square? It is 3 square. Okay, now this is 0. Take next group of numbers, that is 99. Now double this quotient and keep it here, which is 6. And now if I take any digit here, this has to be multiplied by that digit only. For example, if I take 1 here, I have to take 1 here again and multiply this 1 and 61 and take the answer here. If I take 2, I have to take 2 here and multiply 2 and 62, that is 124, which is not possible here because my number is 99 only. So I am using only 1. So 1 and 1. So answer is 61. If I remove 61 from this, it is 38. And next I'll go for the next group, that is 19. Now again double this, it will be 62. Okay, now 62, that means 620, 1 into 1, it will be 621. My answer is very far from that. So I hope 621, to reach 3000, we have to at least use 5, because 5 into 600 gives me 3000. Okay, it will go to that, and 20 into 5 will be 3100, like that. If I add another number like another 600 to that, it may go near to this. So that's why I'm going for 626 into 6. I hope you understood why I took that number. So 6 6 36, 6 2 is 12, 6 6 36. So 3756 exactly. The number is very near to 3899. Another number cannot be possible. If I take 627 to 7, it will cross this one. So here it will end up as 155, right? Sorry, not 155. It's 44 and 9. 143. So no, nothing is existing there, and I have to. Okay, sorry. I have to use this again. So 316 addition. I mean double than that. It is 632. I have to take zeros here now, so that it will go in decimals. Okay. Now this is point. So I have taken zeros there. So 632 something into 1 into 1. It will be 6321 again. So if you observe it carefully, it is 12,000 is very near to 14,000. To make it 12,000, I'll go for 2. If I take 3, it will go 18,000. It will cross this one. So I'll end up here only. So 12,644. Okay. Now again take that. So it will give me 1,756 like that. Again 0. So if I take 0 again, obviously again 2 has to be repeated because it is not crossing 1800. So again 12,644. So it gives me 5, not even 5. 4,900 something like that. So to make it as 4,900, I'll do it. I'll double this again. So it is like 31622 like that. So like this, we will find the exact value of square root of 999. Okay. So I hope you understood this type of questions, and you have to find what is the cube root of 5 5s. So this is your problem. The answer is not ending with 5 again. Okay. You may have the misconception that again applying the shortcut method, that if this is ending with 9, the answer can be ending with 3 or 7 like that. Here also you may have misconception that the answer may be ending with 5s. Okay. Find the answer and comment in the comment section. Fine guys. So this is the way square root can be, the square root questions can be used. But yes, the usage of square root doesn't end here. Why? Because sometimes the problems may look easy like this. Find the prime number in the following numbers. Okay, they may ask this type of question. For example, can you say 181? 181 is this prime number or not? You already know divisibility rules of 2, 3, 4, 5, 6, 7, 8, 9 up till 11, at least up till 11, right? Now if you apply all these things, you know that it cannot be possible. But what may, it is a multiple of a 13 or the other prime number, the next prime number of 13, 17 like that. So how to find whether it is a multiple of 17 or 13? Yeah, you do have rules for 13, 17, 29, 23 like that. Every prime number do have some rules for finding the multiples, finding the divisibilities. But if in exam, if they ask, or if you end up finding the prime rule of 181 or not, whether 181 is a prime number or not, then which rule you have to follow? Then comes your square root very hand. Okay, you will apply square roots again here to find whether 181 or any number is a prime number or not. How to find it? So can I find square root of 181? I know it cannot be, because 181 is not a perfect number. So what is the nearest number, nearest perfect square to 181? So if you know perfect squares very well, 13 square 169, 14 square 196. So it is between 181 and 196. So approximately the square root of 181 will be greater than 13.13 and it will be between 13 and 14. So on a round figure, I'll take it as 14. Okay, I'm rounding it off. It's not actually 14. I'm rounding it off. The answer is 14. Now you have to check how many prime numbers are there less than 14. Okay, what are they? 2, 3, 5, 7. What else? 8, 9, 10. No, 11. Next is 13. Yes, you have to check divisibility rules of 2, 3, 5, 7, 11 and 13 on this number. If it is not possible, if the number is not divisible by any of the prime numbers less than the nearest square root of 181, then the number will not be divided by any other number. Okay, that is the rule, and that's why square root comes handy to find prime numbers. So you already know it is not divisible by 2 because it's not an even number. So no need to find the divisibility of 4, 6, 8, 10 like that. Okay, that's why I have skipped it. And what about 3? Is it the decimal sum is 3, 6 or 7 or 3, 6 or 9? No, it's not. So even it's not possible by 3. And 5, obviously you know it's not because it's not ending with 5. So it is also not. And what about 7? Now 1, 2 is 2. The last digit of 181 is 1. If I multiply with 2, it is 2. And I have to negate from that. It will be 16, which is not divisible by 7. So it is also not possible. 11, 1 and 1. Add them to 8 minus 2. It is 6. Again, it's not possible. And check for 13. If you know the rule of 13, it's okay. If not, you can directly check it. 13 ones 13. 5 is the remainder. 5 1 51. It's not coming in 13. 91 comes in 13. 13 multiple, but not 51. Okay. So if even 13 is not possible, divisible. So 181 is a prime number. Okay. I can declare any number as prime number like this with the help of square root. Fine. So I hope you got how to use square roots in your examinations and how to find prime numbers if you are not aware of the prime numbers more than 100. But I warn you guys, you have to know prime numbers up till 100. Okay, from 1 to 100 you have to know how many prime numbers are there and what are they, because they will come handy when you work on these things. But if you don't know even that also, we cannot help you guys because it is very much required. Okay. So this is about this model, and we are going to meet in the next model. Thank you.